Hello, and welcome back to another video. In this video, we will be setting up an existing NodeJS API to use TypeScript. Note that this will not be a how to use TypeScript, but rather how to set up a project to allow the use of TypeScript. First thing we're going to need to do is install a few npm packages. So we're going to run npm I, short for npm install, TypeScript, ts-node, ts-node-dev, at types node, and at types express. So the first one is to allow the compiling of TypeScript files. The next one, it works in the same way as running like node server.js or node index.js. And then tsnode-dev works in the same way as nodemon works, so allowing hot reloading and all that. And then we just have some types related to node and express. This allows TypeScript to not error when we're using node or express specific items. So we'll go ahead and run that. Once it finishes installing, we'll need to install a couple of these packages globally in order to allow the use of certain commands in the terminal. So we'll run npm i-g, the flag that tells the system to install it globally. The two that we need are TypeScript and tsnode. So we'll go ahead and run that. Again, that'll just allow us to be able to use commands in the terminal. And we'll run tsc, which is the TypeScript compiler, init. This will generate a tsconfig.json file. And yeah, now our project is set up to use TypeScript. So what we're going to want to do is, obviously there's a whole bunch of different options here. We're going to uncomment and update some of these. So the first one is going to be allow.js. If I can just find it, there it is. Alright, so allow.js true. This will allow TypeScript to compile JavaScript files that we may have in our project. The next one is our out directory. So I'll comment it. Here you can see that it's by default set to the root. We want to change this to output to a dist folder. So it doesn't exist right now in our file structure, but it will create one. This just keeps all the compiled code in a nice neat package. Next one is strict. We want to set that to false. Oh, here it is. Okay. I'm going to set that to false. So this will allow us to build or convert our application to TypeScript step by step, doing one file at a time. If you don't, if you have this set to true, then it will immediately error in every single file, saying there are non-defined types and all that stuff. So this just gives you a bit of a break when initially converting. The next one, we need to tell TypeScript that this is a NodeJS project. So let me see, module resolution, there it is. Okay. So we'll just uncomment that. And then we want to tell TypeScript what files it needs to actually compile. So down here, outside of this compiler options object, we want to create the include property. And this will be an array with two relative paths. For us, it'll be source slash star star slash star.js, and then the same thing for our TypeScript files. So this is a regular expression string. It's saying go into our source directory, and then within every folder that is there, every file that ends with JS or TS, compile that into our dist folder. So there we go. Next, we are going to make some updates to our package.json. So currently we have our start script. It runs nodemon on server.js at the root level. This will be moved, and it will actually be a TypeScript file. So since nodemon can't run TypeScript files, we need to run the compiled server.js, which will be located in our dist folder. We want to create another script called post install, and that will run tsc. So it'll compile our project into JavaScript after we run npm install. And then we're going to create another one, dev, which will function in the same way as running start as we currently have it, nodemon server.js. But this will use tsnode dev. We pass it the respawn flag, which tells it to hot reload. Transpile only. This acts as a performance booster. So instead of actually converting the TypeScript files into JavaScript and then placing them into the dist folder, it will just compile them in real time. It won't actually output the files, so this saves a lot of resources. And we need to tell it to compile everything. The entry point. So like up here we have dist server.js. This will be source server.ts, since tsnode dev can run the TypeScript files. And that takes care of the package.json updates. Next we go into our server.js. First I want to create a source folder and move all of the relevant files into it. So, here we are referencing source, and then also in our tsconfig we're saying compile the source folder. So this just ensures that anything at the root level stays as we need it, but then it's only looking at the stuff in the source. So we're gonna move our routes folder, our validation folder, our utils.js folder, and our server.js file into source. Alright. And now, since we have moved that, and since our project is using Swagger, we need to come into our server.js file, and we need to update this API's path. So this path is relative from the root. So even though our server.js file is located in source, this won't work. It'll look when Swagger starts, it'll look for all of these JS files inside the routes folder at the root level. So what we're going to have to do here is just simply add source, and that takes care of that. Our Swagger should load no problem now. And that kind of takes care of our TypeScript conversion. So now we're free to, or we should be free to rename these to Typescript, and I'll just rename these two. So next we're going to run tsc in the command line to compile it. Now you can see the dist folder here, and you can see server.js and utils.js are both JavaScript files, and we still have our server.ts and utils.ts. If we come in here, you can see looks exactly the same in this case, because we don't have any, we haven't added any TypeScript to it, but yeah. And now let's give it a run and see if it actually compiles. So we'll run npm start, and now we have an issue. Because I only installed the specific ones, so let me run npm I to install all of the packages. And now it's running tsc, you can see up here. So it automatically compiled after we ran npm I. And then npm start, let's see. Perfect. So now our API is running on port 3000 localhost using the dist server.js. As of right now, you're free to start converting to TypeScript. Simply change the file extensions from JS to TS and start adding type definitions. However, since this particular project also uses JOI, I'll show you how to generate interfaces from the validation schema. This will save you some time without having to create your own interfaces. So first we'll need to install the JOI to TypeScript package. So npm I JOI to TypeScript. And what this will do is it'll actually generate the interfaces from our validation schema. So we're going to, inside of our source folder, we want to create a new folder called interfaces, and this will hold our automatically generated interface files. We are also going to create a helper script. So within the source root, we will create a new file called generate validation interfaces.ts, and what this is going to do is actually perform the conversion. So it'll utilize that package that we just installed, JOI to TypeScript, and it will automatically generate the files. So first thing we're going to do is import our convert from directory method from the JOI to TypeScript. So require JOI to TypeScript, and then we are going to create an async function types, and this will return a promise that returns void, aka it doesn't return anything. We're going to add a couple console logs just to show that it is running as expected, and also tells us when it's finished. So we'll start running JOI to TypeScript, and then we're going to store the result from our, well, not ours, from the convert from directory method, and we're going to pass it a couple configuration options. So the first one is schema directory, and this specifies where the schemas exist. So in our case, it's source/validation. And again, just like in the server.js with the Swagger routes, it is relative from the source. So it's more like a absolute path, I guess. next we need to define the output directory. So type output directory, and again, it's relative to the source. So relative to the root. So source interfaces, which is that folder that we just created. And we're going to add debug true. So this just allows the debugging to make it easier to debug. So down here, we are going to check if we have a result, and if we do, then console log completed JOI to TypeScript. And if we don't, then the conversion failed. So failed to run JOI to TypeScript. And lastly, down here, we're going to call our types function. So this is just a nice, neat, containerized function. And then once we have that, then we go back to our package.json, and we'll create another script called JOI to TypeScript. And this will call tsnode./source/generate validation interfaces.ts. So this will just call our generate validation interfaces file, and it'll run this conversion. So now if we go down here into our terminal and we run that JOI to TypeScript, it'll perform the conversion, and no schemas found. All right. I think it's because we didn't convert this to a TypeScript file. So let's go ahead and do that. Validation.TypeScript. And then we should now see it compiling correctly. Yep, okay. Running, validate, so it will list out each of the files that it converts. So in our case, we only have the one file, which is validation.ts, and then it completed. So now in our interfaces, we should see these two files, index.ts and then validation.ts. This one, they're both automatically generated. And it even says up here, automatically generated by JOI to TypeScript. Do not modify this file manually. So this one just adds instead of having to reference each file directly, you can just say, hey, import interfaces from /interfaces. So just makes it easier to import. And then in here we see we have 3 interfaces. So the first one is create entries, next one is delete entry, and the last one is update entry. These names are directly derived from each of these. So here, create entries using camel case, update entry, and delete entry, and it automatically sorts them based on alphabetically. So here we see we have entries, which is an array of items with title and due date. And if we go back, where is it? There we go. Okay. Create entries. It's an entries array with due date and title. So yeah, it makes it super easy to convert. And then another thing that we can do, so if we're back in our actual validation schema, we can, at the end of the chain, so for create entries, I'm going to add a meta attribute. This is going to have an object that has class name, and I'm going to uppercase this, or yeah, I'm going to add I for interface, and then I'm going to make it titleized. So create entries. And now, if I run the compiler again, then we should see in here that the name has changed. So that class name specifies that I want this to be named something specifically. So we can do that for all the other ones. We'll go down here and class name, meta, class name, I update entry, and then same thing for the delete entry. Class name, I delete entry. Run it one last time. And there you go. I delete entry and I update entry. So it's a super easy way to automatically generate these interfaces without having to do all that legwork. And then you're free to use this in whatever functions or routes that you're to type them for what you're expecting. So I hope that you found this video helpful or interesting. Hopefully both. If you did, please remember to leave a like and subscribe. It helps more than you may realize, and I hope to see you in the next one. Thank you.